All right, let's dive into one of the most fascinating, mind-bending topics out there, time travel. Is it really just for the movies, or could there be a secret path to the past hidden in the laws of our universe? Well, the whole conversation really starts with one classic and kind of dark question. You've probably heard of this one. It's the grandfather paradox. And it cuts right to the heart of the problem with time travel, which is all about causality. I mean, think about it. If you go back and prevent your own birth, then how did you ever exist to travel back in the first place? It feels like a total logical dead end. But for a little while, the door to the past was actually cracked open by one of the greatest thinkers of the 20th century. So our story really gets going back in 1949 with this absolute genius, a logician named Kurt Gödel. Now, he was good friends with Albert Einstein at Princeton, and he thought, you know what, I'm going to take a look at my buddy's famous theory of general relativity. And what he found, well, it completely stunned the world of physics. What Gödel found was a mathematically perfect, totally logical model of a universe that was completely allowed by Einstein's own equations. But this universe had one very, very strange feature. It was spinning. And that rotation had this bizarre side effect. In Gödel's universe, traveling back in time wasn't just possible, it was basically built into the fabric of space-time. So how on earth does that work? Okay, so general relativity tells us that anything with mass and energy literally warps the fabric of space-time, right? Gödel just took that idea to the absolute extreme. He pictured a universe spinning so fast that it dragged space-time along for the ride. And this spinning would get so intense that it would actually start to tilt what physicists call light cones, which is basically the boundary separating your possible future from your definite past. If you could tilt those cones far enough, a path that's always moving forward in its local area could actually loop all the way around and bring you right back to where and when you started. And you know, physicists have a name for this kind of pathway. It's called a closed time-like curve, or CTC for short. And that is the honest-to-goodness scientific term for a time machine. The really wild part is that if you were on one of these CTCs, you'd never have to go faster than the speed of light. You'd just be moving into your own local future, moment by moment, but the twisted-up geometry of space-time itself would carry you back to the past. So Gödel had just found a potential physical basis for time travel. But here's the catch. Science fiction writers had already been playing in this sandbox for decades, and they had already figured out the massive logical flaw at the center of it all. This is a perfect example of how fiction often asks the really big, thorny questions long before science can even start to answer them. As early as the 1930s and 40s, writers like Catherine Moore and René Barjavel were grappling with the exact same paradox that Gödel's universe made physically plausible. They already understood the terrifying implications of breaking that chain of cause and effect. I mean, let's just state it plainly. It is a perfect contradiction. The effect, which is you traveling back in time, ends up erasing its own cause, your birth. It's this logical knot that seems to make any meaningful travel to the past totally impossible. So how do physicists even begin to try and untangle that? Well, there are two main schools of thought here. The first is called the self-consistency principle, and this basically says the past is written in stone. You can travel back, sure, but you can't change a single thing. If you try to shoot your grandfather, the rifle's going to jam or you'll trip on a rock at the last second. Something will stop you because the universe knows he wasn't shot. Your actions were always a part of the history that led to you. The other idea is the many worlds interpretation. In this version, when you kill your grandfather, you just splinter off into a brand new timeline, a new parallel universe where you were never born. Your original universe is perfectly fine, but you're now stuck in a new reality you created. For a while, though, it seemed like the universe itself had its own built-in failsafe to prevent these paradoxes. A deeper understanding of Einstein's equations suggested that spacetime has, well, it has dead ends, which would make Gödel's perfect loops impossible in our real world. Yeah, in the 1960s and 70s, you have these two giants of physics, Roger Penrose and Stephen Hawking. And they proved that under pretty much any normal conditions, general relativity inevitably leads to something called singularities, these points of infinite density, like what's at the center of a black hole or the Big Bang itself. And a great way to think about this is to picture the insane gravity of a black hole as a powerful lens. You know how a magnifying glass can focus sunlight to a single hot point? A black hole's gravity does something similar, but with all the possible paths through space-time. It focuses them all down toward one point of no return, the singularity. So here is the crucial point. These singularities act like cosmic roadblocks. They are the ultimate dead end for any path through space-time. And if every path eventually hits a dead end,
well then no path can ever loop back on itself to form one of those closed time-like curves. It really seemed like time travel was forbidden by the very same laws that first seemed to allow it.
But, physicists, if the universe has rules, they are going to look for loopholes. And it turns out the singularity theorems only work under certain assumptions. And if you could just find a way to violate one of those assumptions, maybe, just maybe, you could build yourself a time machine. The most famous loophole is probably the traversable wormhole, a shortcut through space-time. The problem is, a wormhole would be incredibly unstable. Left to its own devices, it would just collapse into a singularity in an instant. So to keep it open, you'd have to prop it open with something really, really weird. You would need something that physicists call exotic matter. And this isn't just like rare stuff from another planet. This is matter with negative energy, which would essentially have anti-gravity. It would push space-time apart instead of pulling it together. The thing is, we've never ever seen it. We have no idea if it even exists, let alone how to make it. And this is where science and fiction cross paths again in this amazing way. When the legendary Carl Sagan was writing his novel Contact, he wanted a way for his characters to travel across the galaxy that was at least scientifically plausible. So he called up his friend, the physicist Kip Thorne. And Bourne's answer was this: a wormhole, held open by this exact type of exotic matter. And that idea actually kickstarted a whole new wave of serious research into the topic. So this brings us all the way to the modern era, where the whole debate has taken this incredibly radical turn. Physicists working on a theory of everything, or quantum gravity, are now asking a question that I think Gödel himself would have loved. What if the entire problem is based on a totally wrong assumption? What if time isn't really what we think it is? First, Stephen Hawking tried to put a formal ban on time travel with something he called the chronology protection conjecture. He basically proposed that some law of physics that we haven't discovered yet must always step in to prevent paradoxes, essentially making history safe from any meddling time travelers. But an even more revolutionary idea is starting to take hold. I mean, Gödel himself was partly driven by this philosophical belief that time was just an illusion, and now, decades later, some of our most cutting-edge theories in physics are pointing in the very same direction. For example, take a theory like loop quantum gravity. It's one of the leading candidates for a theory of everything, and its most fundamental equations don't even have a variable for time. In that view, time isn't this river we're all flowing down, it's an emergent property, kind of like how the feeling of hot or cold emerges from the jiggling of atoms. Other theories actually build the universe with causality baked in from the start, which would make paradoxes impossible by definition. And that leaves us with this final, absolutely profound question. This entire debate about going back and forth in time assumes that time is a real, fundamental dimension that we can navigate. But if it's just an illusion, something our brains create from deeper, timeless quantum processes, then what are we even talking about traveling through? What does that even mean for our idea of a past, a future, and the very concept of a journey through time?